Assalamualaikum and a very good day. My name is AnwarSyaakirin bin Zulkifli from 4 Bank Section 5. For my final year project, I did a project on the classification of Pterygium using deep learning techniques. Before we get into details of the project, I would like to introduce what is a deep learning. Deep learning is a branch of machine learning that teaches computer to do what comes naturally to human, which is learning from the experience. It is used to perform many types of image analysis, such as classification, segmentation, and object detection. In this project, I will be doing an image classification task to detect the Pterygium disease from the corneal eye region. I will be using MATLAB, image processing toolbox, and deep learning toolbox to perform the classification process. Pterygium is a type of eye disease that occurs at the cornea and the pupil region. The pterygium tissue can be seen grow from the part of the eye that close to the nose. The pterygium is developed when a person are working under the heavy UV sunlight with a dusty environment. Now, let's see the images that will be utilized for the deep learning classification. These images are obtained from the very different resources. The normal eye dataset was obtained from the UBRIS V1, which also an open source dataset, while the Pterygium dataset is obtained from the Australian Pterygium Center provided by Supervisor. For the Pterygium classification task, the convolutional neural network, also known as CNN, is used to extract the features from the image. It is proven by many deep learning practitioners that the CNN works best on image analysis. The pre-trained model named ResNet18 is used for this project. The classification process begins with the input image are being fed into the convolutional layer. The layer will perform the feature extraction process on the image while also reducing its dimension. At the 17th layer, the feature extraction process is ended. All the extracted feature is flattened by fully connected layer before fed into the softmax activation function. The softmax activation function will determine the input image. Either the image will be labeled as normal or Pterygium. Let's see the network training using MATLAB. For network training, this is the code that I use to train a deep learning model. First of all, we insert the dataset into the MATLAB. Since the model we use to be trained on is ResNet18, the images in the datasets need to be resized into 224 in width and 224 in length. After that, the images will be undergoes the augmentation process. The augmentation process purposely to extend the small dataset that we had to prevent the overfitting. Okay. The code here shows how the transfer learning process works. The last trainable layer, which is the fully connected layer in ResNet18, and the classification layer will be replaced with the new one. And then for the training option, I'm using the stochastic gradient descent optimizer to learn the features from the images. Since I will train all of the model with different hyperparameter instantly, so the mini batch size and the initial learn rate will be set up at the experiment manager. Instead of training the deep learning model one by one, I will use the experiment manager from the MATLAB app to train all the models in abundance. Here, we can see this is the values of hyperparameters that I want to train on. Here, we can see all of the model has been completed training, so we can view one of the model to see its training graph. So by clicking the training plot, we can view its training graph. Here we will see the training graph of the model. Each model with different hyperparameters will be trained 10 times before finalize the accuracy of the model. The average accuracy will be used as the final accuracy of a model. The performance of each model in each combination of hyperparameter are recorded into this table. The highlighted metric, which is the accuracy, will be the one that we will focus on. From this table, we can see there are multiple models with the hyperparameters that train very well, but how do we know if those models are genuinely doing good at learning the features of the image or just learning the noise? So, to overcome this problem, we tested those models with the unseen test set. This way we can identify which model trained the best. Based on the new table, we can see there is an additional column that recorded the accuracy of those models in the unseen test set. From here, we can identify the best performing model based on the accuracy and the standard deviation. Apparently, the model that has the mini batch size of 8 and the learning rate of 0.001 has the highest accuracy, which is 99.97%. It also has the lowest standard deviation with 0.01, which indicates the model is very stable. Now, we will go to the network testing using MATLAB. From here, I will show the testing process with the MATLAB code. I have prepared a folder consists of normal and Pterygium images combined. I also have exported the train ResNet 18 into the workspace. Right now, I want to classify all of the images inside the folder. Then, I will take 4 images out of that folder to see the accuracy value of those images that had been classified. Here, the figure 2 shows an example of the images that had been classified. Nicely done, all shown images is classified with 100% accuracy. The confusion metric also shown there are no misclassification images. Hence, the model achieved the perfect score. That's all from me. Thank you.